Ian, this is a top secret file. The Soviets are after me. I need you to have this. This is all the information you need to supply information from our rovers to our orbitals on Mars. Here you go.
Gentlemen, today we present to you the solution we had been discussing. The M2E, Mars to Earth link, where we use quantum satellite communication to securely transmit data from rovers and satellites using qubits, which are just bits, zeros and ones, which can stay in superposition, which means they can stay in between states. And we use some encryption algorithms, which also help us encrypt our data. So here we can see a small diagram. And then let us go to our logs. So our code basically uses these sorts of logs. And then to the About page. So here we are, Ian Kotaria and Vihaan Vashistha, two 10th grade students passionate about science and innovation. And from this hackathon, Space Hack 2025, we came up with the Mars to Earth link project. So let us move to our projects page. Whoa! Is that an alien? Oh my god, where's Vihaan?
I have the photos. We need to send this to the orbiter immediately.
No, we can't let the Soviets know about this.
True. But how are we gonna send it to the orbiter?
Well, is there some secure method? We need to think fast.
I mean, there was this one thing that I heard of in quantum mechanics. There was this process called sifting.
Oh, I think we should do that right now. We need to do it fast.
Yeah.
End of flashback.
So essentially, sifting is this process of losing 50% of the qubits, even though we're still maintaining all of our information. We lose 50% of the qubits to make sure no one eavesdrops on it. It basically alerts anyone, and if it alerts us to see if anyone is eavesdropping or interfering with our radio waves. So here you can see the code. We're using the BB84 encryption method, which basically encrypts our message and is only being able to decrypt it at the orbital. So as you can see, this is our terminal output. You can see the quantum key exchange has been successful, and that was our part 1 of our mission.
Flash.
Oh no, Vihaan! Our energy reserves are running extremely low. This is a red alert. We need to send
what should we do? If only there was a way to efficiently send all of our information to the satellites.
Oh no, this is horrible.
End of flashback.
Alright, so this is stage 2. This is the transmission from the orbiter to Earth using the Deep Space Network. Here we're using Grover's algorithm, which is basically a form of efficiently communicating and using satellite hopping to maximize energy efficiency. So here you can see our different nodes and the paths that are taken by several qubits or using the Deep Space Network. So all these are satellites and the paths of the qubits. Here is our Python mockup. As you can see, we're still using the BB84 encryption method. We have our different nodes. And we're using binary variables to find the efficient path.
So Vihaan, how are we exactly using the Grover's algorithm to help us in this project?
So essentially, Grover's algorithm and also Dijkstra's algorithm help us find the essential path, like the shortest and the most efficient path to send qubits over one satellite to another.
So sort of this route optimization which I see here.
Right. And this is the terminal output. As you can see, our data transmission was successful. And that is our presentation. Thank you.
Thank you so much.